Talk about the concept of exception handling. Now, we've done some exception handling already, just not with the particular capabilities that C++ provides us. But we're always handling different kinds of exceptions. Exception basically means something that occurs in interacting typically with the user, but sometimes also with external devices, etc. That's in error. Not the same thing as a syntax error or some other compiler error, but an error that occurs in logical processing or something along those lines. So we want to talk about what an exception is, how do we handle them, how we can specifically use some C++ capabilities, the try, throw, catch metaphor, if you will, and some of the exception classes that already exist. And then we'll also learn how do we create our own, etc. So the idea behind an exception is some undesirable event that occurs during execution. We can either have programmer-supplied code that acts upon the exception and either tries to correct it or terminates the program, or we can let the operating system basically handle the error and terminate the program. So we have some choices about who we let handle the program. Now realize that, of course, usually when we let the operating system terminate the program, it terminates with prejudice, meaning it's not going to try and do any recovery, not going to close down any files, it's just going to immediately exit. And so we may want to do that. The first tool that we have to handle some kinds of exceptions, and some of you may have used these already, is the assert function. This is a built-in function that basically checks to see if an expression that we provide to it meets certain conditions. If the conditions are not met, it terminates the program, providing an appropriate error message. One of the examples of these would be things like division by 0. So if we check the divisor before we do this, then we avoid the immediate operating system termination of our program, and we can handle with appropriate error messages. So in this first example, we have a simple program that creates a dividend, a divisor, and a quotient, and then asks for the values, and doesn't do any testing and does dividend divided by divisor. So if the divisor happens to be 0, since we haven't checked to see if it was by the user, then we're going to get an operating system error, a divide by 0 overflow indicator from the CPU, if you will, that's going to cause our program to terminate around line 8 in this particular example. So, and here shows what that problem is. And notice we don't get a very interesting error message, just something that the operating system defines that it needs to close. In the next example, we've put in sort of the old standby C style test, where we said if divisor is not equal to 0, do the work, otherwise print out our own error message. So this is a little bit better, but we can make our lives a little easier using some of the built-in tools. So in this case, we would get whatever error message we provided. Using the assert, notice that instead of having to do an if test, we can simply assert that the divisor is not equal to 0. If it is equal to 0, then the assert macro, if you will, the assert function, will do some error handling and messaging for us. But if not, then we'll just continue to go. And so here it tells us exactly what the problem is and exactly where it occurred, which is, from the programmer's perspective, more useful, although it's not as descriptive per se to the user. This would be a helpful piece of information for the programmer if this were to occur in a program. It tells what assertion failed, in this case divisor not equal to 0, and it tells exactly which file and which line number that assertion failed on. Now remember, these are runtime errors. These are not compile time errors. So these are things that would occur after you've completed the program and perhaps even put it into production. So it would be useful information for us to have. Another mechanism we have, which could be used to handle this problem as well as others, is called the try-catch block mechanism. It's sort of a baseballish type analogy where we try to execute a block of code and then we catch various exceptions that might occur in that block of code that are thrown by different things that might occur. So they have to be thrown inside the try block, and then we catch them in the catch block. And this is nice because we can catch several different kinds of errors for a particular block of code. The key here, though, is that you don't want to just encapsulate your whole program inside one big try block. You want to do it sections at a time so you can catch targeted exceptions. In other words, in a particular block of code, depending on what's going on, only certain kinds of exceptions may occur, and we can catch those. And then we can have another block catch exceptions there. If we try to do the entire program, especially if there's lots of function calls and things like that in there, then we may not know all the possible exceptions that might occur. So some of them might slip by us and then have to be handled by the operating system, which might terminate our program with prejudice, which may cause problems in data, as well as may have been situations we could have corrected if we had set up the try-catch blocks more appropriately. So the idea is that anything that could generate an exception is placed inside of a try block, and this could be a subsection of code in main, it could be a section or even the entire function block in a function, depending on how large it is. So any block of code, any set of lines of code, we can put inside one of these try blocks. And then there will be a catch that goes with the try block, or maybe a set of catches that will execute only if one of the exceptions occurs. Otherwise, we skip over the catches and go on to the next executable code if there is any. So there could be one catch or multiple catches. We'll start out with a single one and then we'll add some more. The catch block then says what kinds of exceptions it can catch, and then has exception handler code in it, which typically is going to end up providing some error and data recovery kind of information, maybe doing some shutdown, and then eventually probably terminating the program. Although in some cases we may have catch blocks that can fix the problem if it's something that we can correct and retry, if you will. Okay. If we have a catch block that has a ... in it, or ellipses in place of the parameters, then that's what we call a default catch block, and it'll catch any of the exceptions that weren't already specified in different catch blocks. So we can kind of have a default case, much like we have in the switch statement in C. So in general, it looks something like this. There's a try block with some executable code in it, and then different catches for different kinds of exceptions. Some of these exceptions might have to do with I/O, like opening a file or trying to read or write to a file. Others might have to do with arithmetic operations, like the divide by zero, and then we might have a default handler for anything that wasn't one that we explicitly called out as being prepared for, if you will. So let's look at how these work in real code here in just a second. If there's no exception, though, in a try block, we need to understand that all the catch blocks are ignored. So we'll continue executing the code after the last catch block. If the exception is thrown, then the remaining statements in that try block are ignored. So we go immediately to the error handler of the catch block. So we'll skip the rest of the code in that block if a particular error occurs. If an error occurs, then the program searches the catch blocks looking for an appropriate handler. If it finds one, then it executes code only in that catch block. If it doesn't find one and there's no default, then the exception will be thrown up to the next layer of the program, which could be, if it happened in a function call, it could be main. If it happened in main, it could go to the operating system. And so in general, we can have catch blocks that have different arguments. In this case, this catch block says it would catch an exception that's thrown with an integer value, and we'll see how to do this in just a minute. There can only be one parameter to the catch block, but it does not have to be an integer. We'll see some other examples as we go through. If we want to create our own exceptions, in other words, ones that aren't automatically created by, for example, CPU operations like divide by zero, or automatically created by some of the built-in C++ classes like the IOStream classes for reading and writing to files, then we simply say throw, and then whatever it is we want to throw. This could be an integer value, it could be an object, it could be some other variable, and then we can create a catch block that matches that, whatever type of data that is. It can be an object, an anonymous object. I remember now that we've created this, then throw is a reserved word. We can't use that to name our own functions and stuff now. So let's look at an example. These are examples of throwing something. So in this example, throw expression, throw 4 would throw a constant value. Throw x would throw the value of whatever the variable x is. Throw str would throw the value of a string. And that throw x should probably be throw num, since that's the variable we created. That would throw the value of the string str, or I could throw an anonymous string. In other words, it's one that's basically created on the fly, so it doesn't have a variable name, and that's what the fourth example shows. Catch blocks can be put in whatever order, but they should be ordered in such a sense that the likelihood that they would occur, and we would always put the default catch block, if we're going to have one, the one with the 3 dots or the ellipses, should always be at the end, because if we put it before then it'll match everything, and it would always be executed no matter what kind of exception. So the ellipses one should always be at the end. So let's take a look at a simple example. In this example, this is our dividing example again. Notice the code that does the main work inside this one is all encapsulated inside of a try block. So we've got all the input-output. So in cout or cin could throw exceptions. And then we've got the throwing of a value if the divisor is equal to 0. So we throw a 0 in this case. And in this case, we're catching an integer. And we do that before the dividend divisor. Now we'll look at some different ways to accomplish the same purpose as we go through here. But this shows one, and then there's a catch for the integer value, and then the rest of the code on the next page, simply printing out some information inside that catch block, and then the end of the code, the return. So if we were, for example, to type in a 0, on line 14 we'd get this division by 0 output from the exception handler. Now this may not seem easier than doing the assertions, but it is when we have multiple kinds of things that could occur in each block. In fact, this block could have other kinds of I/O type errors occur that we're currently not handling ourselves, but the operating system would handle. So the cin or cout could throw exceptions, more likely cin than cout. So here we're modifying it slightly, still going to use an integer value, but instead of throwing constant 0, we're going to throw the divisor, which of course will be 0 if we satisfy that if test. So the result would be the same. We'd get the same information, just throwing the value instead, which might be more appropriate in some examples. And in this particular part, this next example, we see the try block opened again, and then on the next page it's shown. It's throwing a particular value if the divisor is 0. It's also throwing a string if the divisor is less than 0, and if cin failed for some reason, then it's throwing whatever the input string is. So now we have 3 possible things, 2 of which are strings. So we have 2 catch blocks, one to catch an integer value, and that would say that, hey, we tried to divide by, in this case, 0 is what it's going to print out. Or we catch a string and we print out the appropriate string. So in this case, if we divided by a negative number, we'd get the exception that says a negative divisor. I mean, we don't want to be able to divide by negative numbers, not that that's not mathematically possible. If we put in some value that is not a number, like G in sample run 3, then we get a failed input stream, because the cin is going to fail, and this is what would have happened before, except we would have gotten a generic operating system error message. Here now we can specify what the problem is. In this case, the input stream is in its failed state because we got a bad value. And of course, if we put in the 0, we get the divide by 0 message. C++ actually has a class exception that we can use as well, so we can throw objects. So we can provide, remember, for the catch, the throw and the catch, we can only throw one thing, but that thing could be an object, so it can contain a lot more information and several variables, but because we can only throw one thing, we can throw the object and have all that information encapsulated in that object, and then we can extract it in the catch block and still satisfy the only one argument for the throw and catch metaphor. So there are some already existing classes derived from exception. There's a logic error and a runtime error. Those are defined in a particular header file. And there's also a class for invalid argument to deal with illegal arguments used in function calls. There's one for out of range for strings. There's also one for a length error. etc. All these particular ones have to do with the string class, so it throws them if those things occur. Operator new throws a bad allocation exception, so instead of us just having to check the pointer to see if it's null, we could instead put it inside of a try block and then get the bad allocation error. The general class runtime error deals with errors that occur during program execution, so there's overflow and underflow, which would be as a result of an arithmetic operation, so we can catch those. And here's an example of using some of those, in specific the out of range and length error. So here's a program that creates and allocates some string objects, string 1, string 2, and string 3. We write something into the string object, test its length value, print out the value of length, perhaps set up a substring, force some values into the range, and then we have the catch block, which would tell if we're out of range or if we generate a length error. So in the case of the output from this one, we get the length is 26, then we get an out of range block because if you look at the line 9, we're trying to get a substring starting at value 28 or index 28, and there's only 26 values in this particular string, so we'd get that out of range error in this case, and that's what we see in the line 14 output. For using new, here's an example of forcing a bad allocation just so we can see that it works. So inside the try block, we have a loop that goes through 100 times and allocates a very large block of integers, and at some point we're going to get an allocation error because we're going to use up all the currently available space in the stack because we're allocating 50 million ints at a time. And so depending on how much memory you have, it may take just a few iterations of this loop or may get closer to the 100, but eventually you're going to use up all the space that's in your stack unless you have a very, very, very large amount of memory. And so we'll catch that bad allocation error. So in this particular example, we're able to do 8 of them before we ran out of memory and got the bad allocation error. So these are things you can put in your code. If they never execute, great. It means you never have a runtime error. But otherwise, you can do that. You can also create your own exception classes, usually derived from the base exception class in C++. And that way you can put in your own detailed information about what occurred, and then you can throw that exception example. So in this case, this first example, we've created a class called dummy exception class. And then in the example code, or in this case, class divide by 0, we've got main declared, and we've got this information. We're throwing this divide by 0 object, which is just a dummy object at this point, but we can catch it and then print out an error message. Now, this example is not a very good example since all it does is show us syntactically how to use our own class as the thing we throw, but it doesn't do anything useful. And what we'd really like to do is put additional information in there so that we can use it. So in this example, class divide by 0 has a constructor that takes a string, so we can provide a custom message, but it has a default message in the default constructor, and then also has a function called what that returns whatever the value of the message, and the message is what's in the string that's in the private area. So now what happens is if we have a divide by 0 occur, we throw this division by 0 object. In this first example, it's one that simply will provide the default message, but we can also catch it then, and then we can print out the value of what, which in this case would just be division by 0. We print out that message. But what we could have done in this previous line where we did the throw inside that constructor, we could have provided a custom message. Or we could have put a string inside this set of parentheses right here, and in that case it would have printed out, instead of the generic message which was in the default constructor, down here where it printed out the line 14 message, it would have printed out whatever message that we put in there in the constructor. So we can provide custom output to help ourselves out. Remember, most of these exception handling messages are for the developer, not for the user. Because if one of these runtime exceptions occurs, it means our program didn't handle something properly, or based on user input, there was a problem at runtime. And so we're as much telling the user, hey, there was some problem and we had to terminate, but here's some information you might want to give to your developer so they know what happened. And so in this example, we have this do division function. So in this case, we're creating a function, and then the try block will be inside the function as opposed to in main, so just showing a little differently. And again, we're throwing the division by 0 message, and we get a similar message as the one we got before. Now sometimes inside of a try catch block, maybe there's an exception either we don't want to handle or we want to intercept it, do some work, whatever that may be, including providing a custom error message. But then we want to rethrow it so the operating system or whatever's above us, could be if it's inside of a function we want main, to also deal with this particular error and provide additional information. So we can do that as well, and that by basically rethrowing the information. So we just simply put a throw, and then we may rethrow the same value that was passed to us, or we might rethrow something different, maybe a different kind of an exception object, so that it will be handled appropriately at a higher level, meaning either whatever called us or ultimately the operating system. So again, we can throw any of the kinds of things that we threw before. So we might have an exception class that, like in this example, says I'm going to catch an int, and then I'm going to throw that int, but also some other information. So in this case, we try do division, catch division by 0, print out a message, etc. And then do division, the function is going to throw division by 0. And so we know that, so we know what it throws whenever that occurs. And then inside the exception, there's several things we could do. We can typically, most exceptions terminate the program, but it could include code that might recover from the exception, or just simply log the error and continue running, like in a printed or a file that contains a log that we could print later. Because sometimes the exceptions that occur are things we need to note, but not necessarily things we need to act on. This happens a lot in communications type code, where we want to log the fact that, hey, we tried to send something, but the person wasn't listening or whatever, so we're going to log it and go on, and then we'll try again in a few minutes or something like that. Terminating the program is when we have errors that we know we can't recover from. So either in the code or by where the code continues after the catch block, there's no point in continuing the program, so we print a message and terminate. In some cases, we can fix the error, like if the input from the user was a letter or something, we could simply tell them that that was the problem, reset the input stream by doing a clear, and then giving them a chance to input the information again. And continue to do that until we get valid input. If we're running some kind of a nuclear reactor or monitoring a satellite or something, we can't terminate the code. We just simply need to log the fact that something bad happened or something anomalous happened, and then probably continue running. We can't just shut the program down and say, okay, we're not going to monitor the nuclear reactor anymore or something like that. So typically we'd write an exception into a file and continue to run. And there's a couple examples of doing this. So in this example, strings created in main, we have a try block. It says enter an integer, and if cn is in an error state, we throw the value of the string. And then what's going to happen is in the catch block, we're going to simply print a message. And notice that this try block is inside of a do while. We won't see the while till on the next page. And we'll ask for a number again. And then in the catch block, we simply say we're restoring the input string. We do a clear, and we try to read the value again. And then it's going to go back through that loop until done is true. Or until done is, yeah. While done is false, we'll keep doing this. So we set the value for done, and then we'll keep going. So we'll keep doing this until user enters a valid value. And there are other ways to accomplish that thing through strings. So in this case, notice the user 3 different times has put in values that were invalid, that had text in them, even though we're supposed to be entering an integer. So we restore the input stream, give them a chance again, and finally when we get a good value, in this case 48, we can continue on with whatever the rest of the program does, which in this case is just printing the value. I remember when when an exception is thrown, if we don't handle it, then it goes on up to the next level. And so we basically unwind the call stack until we get to main, and if main doesn't handle it, then we continue on to the operating system, which will always handle all exceptions, usually by immediately aborting the program. And it's just more detail about the same thing. So the stack continues to unwind until there's either a block that handles the exception or the program does nothing and it's left up to the operating system to handle the exception. And there's an example showing how this would work. So in summary, we want abilities to handle undesirable events that occur during program execution, and we have a tool that we can use to do that. Some of them are already built in, so a lot of the existing C++ functions and classes, like all the I/O classes, the standard template library, all of them have exceptions that they throw. When you go look at the documentation for example, iStream or OStream or any of the standard template library functions, in the documentation they're going to tell you what exceptions they throw. And usually they throw exceptions that are based on some other built-in exception class, so that when you catch the exception, you can look inside that object at its various attributes, and you can see not only typically a string that'll tell you details about what happened, but also often there are numbers that represent the degree of severity or some other piece of information that will be useful to you, perhaps an index of a value in a map or something where the error occurred, etc. So being able to throw and catch objects lets us report quite a bit of detailed information. So even if you don't create your own exception objects and you just use integers or strings, you still need to be aware of the fact that a lot of the built-in classes that we use have those as well. And then we've talked about what happens if we don't catch it and how it eventually goes on up to the operating system. We know that catch blocks can only have one parameter. The exception class is a base class that's provided in C++ that we can use as a base for creating our own exception objects, and it's what all the exception objects that are thrown by the various built-in tools use as well. So this is something you don't necessarily have to use in your code in the upcoming homework assignment, but certainly it's something that is useful, and it's a way that we can capture information that the built-in tools and built-in classes in C++ provide to us so that we can know a little bit more about what happens when things go wrong.